Okay, so now this session is on full text search in Couchbase. Right now, these days, text search has become a pervasive enterprise case simply because of the advent of big data. Right, so as solution providers, we have to be comfortable with all the search techniques available. Okay, so here in this presentation, I'll be focusing on full text search on Couchbase. Okay, so this is the agenda I'm going to follow. What is Couchbase FTS and why we need it? Features of FTS, inverted indexes, how FTS scales, right? After that, I'll be talking about FTS index partitioning, FTS index querying. After that, we will have a demo followed by Q&A session. Okay? Yeah. So what is Couchbase FTS? So it is a set of techniques to search text at scale in collection of documents in buckets. Now, we Couchbase we store data as documents in buckets, right? And if you want to conduct search fields in documents, you have to use FTS. Especially if you have to search at scale, right? The underlying principle behind text searching is you create a full text index, right? Indexes are nothing but targets on which searches are to be performed, right? Now, let's say you want to search a field in a certain document. So first thing you do is you create an index on that field and then Couchbase to index them using the engines. Okay. The underlying engine which perform those indexing is called Blave. It's a Go-based lightning fast engine, right? So Couchbase FTS is based on a Go-based engine called Blave. Okay. So what are the advantages of Elastic and Solr? If you take Elastic and Solr, those are the pioneers in search industry, right? But if you integrate Couchbase FTS with the existing Couchbase environment, what are the advantages you get? Firstly, it's out of the box integration with the Couchbase data platform. That means if you want to conduct search in scale, you don't need to go for Elastic, you don't need to go for Solr, right? Simply enabling FTS, it is integrated into the Couchbase platform or Couchbase ecosystem, you can conduct full text search. Okay, and it's more productive. If you want to integrate Elastic search, you have to provide adapters. Providing adapters is the overhead. You have to provide new hardware, you have to have a separate administrators, right? You have to train them, you have to reskill them, right? That's huge overhead. And it simplifies the maintenance simply because you are getting rid of external hardware like Elastic and Solr, right? And the bottom line is you get rid of the cost, right? Cost will be drastically reduced if you use existing FTS engine along with Couchbase. And Couchbase is posing an existential threat for the pioneers like Elasticsearch and Solr, right? So Couchbase is a rising state-of-the-art technology for search. Okay, so now these are the features of FTS. It supports language-aware searching. This is nothing but natural language searching. So if you want to, for instance, if you want to search by beauties, you can obtain results for beauty and beautiful, right? So simply doesn't do one-to-one matching, right? It does relevance-based matching. Okay. The process of indexing like this is called stemming when it comes to natural language searching. Okay. And it supports scoring of results. As I said earlier, it doesn't do one-to-one matching in text, right? It does relevance-based matching. That's the beauty of this FTS, right? And those results will be sorted according to the scope that is determined by the search engine. Okay. And it supports fast indexes. The underlying index mechanism behind the Couchbase indexing is inverted index. If you take Mongo, it is done with, using a technique called B+ index. Right? Inverted index is lightning fast. As a result of that, Couchbase is leading the market in terms of speed when you compare its competitors. And these are the type of queries which are supported by Couchbase search API: match queries, match phrase, regex, prefix-based queries, conjunction. If you want to perform AND operation, you can use the conjunction-based queries. If you want to perform O operation, you can use disjunction-based queries. And it supports numeric queries and real-time queries. Right? Simply, it's a full-fledged conduct enterprise-level search. Okay.
Does that mean require beauties? We will get beauty and beautiful as well.
Yeah, that's natural language search. Yes. At the time it does indexing, it will store indexes which is equivalent to beauties and beautiful. The process of analyzing this text is called stemming. Right? When it performs indexing, it will do the indexing based on the process you define in the analyzer. Right?
So when we Storing the English.
It supports any language. That's the beauty of this FTS. Okay. I'll do some examples.
Okay.
This is how invariant index is stored in Couchbase, right? Simply, it is a key-value map, which is getting updated at the time you add a new document to the Couchbase engine, right? What Couchbase engine does is it will update the index map where the key value is the term, and the key value is the term, and the value is the document IDs, right? So identifying the terms can be customized according to the requirement. To identify the terms is done in a process called analyzing. You can define your own analyzers. So based on the analyzer you define, you can determine the keys. So based on the key, it will perform the indexing for you, right? This is the core principle behind Couchbase searching. In Mongo, it is done in a different way. It's called B++, right? But it is lightning fast compared to the MongoDB indexing. Okay. All right. Let's see how Couchbase indexes, Couchbase scales, right? Couchbase scales considering a principle called index partitioning. Right? Index partitioning is nothing but sharding. Have you heard about sharding? That sharding is simply instead of storing all the data in one bucket, right? If you have multiple nodes in the cluster, it will spread all the data across all the nodes. For instance,
Sharding or sharing?
Sharding. Simply if you take one bucket, that bucket will not be stored in a single node. It will be stored across all the nodes available in the cluster. How it does is one bucket is divided into 1024 virtual buckets. Right? That 1024 will be spread across the available nodes. For instance, let's say you have 3 nodes, right? You get 1024 virtual buckets. So 0 to 399 will be stored in node A. 400 to 799 will be stored in node B, like that. Okay, that's how virtual buckets are working. So at the time it performs the indexes, it will fill all the buckets according to the buckets available and in a even manner. Okay, that's how the Couchbase indexing works. The advantage is once you have multiple charts, the indexing will be faster. So we have more resources available to conduct indexing. And at the time you search, again you have more resources available. So you can conduct MapReduce function in an efficient manner. Instead of utilizing resources across a large index, you utilize more resources in a short index portion. Okay, so this is the principle behind scaling. So apart from achieving scalability, you are achieving more performance also, right? Because of the starting concept. This is how it does the querying. When you send a request to one node, the topology is automatically identified by your program. Right? You don't need to specify which ports you are running FTS. Right? Simply when you send a request to the FTS engine, it automatically identifies what nodes in what node the FTS are running, and it will send a request to one node. Then internally to spread the load across all the FTS nodes. So you have to operate your query across all the charts. Right? The process of doing is called scatter and gather. So it will execute all the queries in all the nodes and finally combine, sort, and resolve this effect to the user. That's how it is working internally. This mechanism is very faster because you are doing parallel search, you are doing parallel querying, and combining. This is simply divide and conquer mechanism. Okay. And the methodology is called scatter and gather process. Okay. So I just gave a rough introduction on how FTS is based on. So if you have a question, you can ask before I talk into the demo.
Yeah, we send the query to a node and not separate the query and separate.
Because index are spread across all the charts, all the nodes, right? Now you might ask where replicas are stored. If the load is spread across all the charts, all the nodes, how replicas are stored? Replicas are also stored as charts in crisscross manner. If you go to the previous slide, the replica of node A will be stored in Y, right? And the replica of node B will be stored in Z. Given that your replica number is 1, if you have 2 replicas, the original data in A will be replicated across B and C. If you define 2 replicas, if you define 1 replica, it will be spread across only one additional node. Okay. you want to achieve full availability and scalability, you have to spread across all the nodes available. Okay. All right. Yeah. The objective of the design is to have scalability at the same time you achieve performance. Okay. All right. So let's go back to the demo. Okay. So first thing I need to do is I need to have a sample bucket. Right. I'm not going to use our available buckets. So what I'll do is I'll create a sample bucket. Now these are the available built-in sample buckets in Couchbase, right? So I'll pick travel sample, right? So we have travel sample. So still, yeah, still being created. Just right. Okay. So so the first thing you do when you are utilizing FTS is enabling such service. This service is not enabled by default, right? Explicitly, when you deploy your node, you have to specify the FTS service. Then only this functionality will be available. Search. Okay. This is the interface that you define indexes, right? And these indexes are totally different from the indexes you defined in M1QL, right? That it uses index service, right? That is different. It's totally different from the index service. And indexes you defined here are around 20 times faster than the indexes defined in M1QL using index service. Okay. All right. Okay. So let's create an index. Okay. Yeah, around 10 to 20 times it's faster. First, let's go to the type of documents. Now, these are the documents created out of that sample bucket. See, so type is airline, name, Bimbe. So I'm just giving a heads up on what is available in this bucket. So airline, Bimbe. So this is airline is the type, name is some baby, ID, IATA www, like that. If I open another document, type airline, same thing. I open something like this. Type airline, Panama, World Airways, country United States, like that. Okay, so now these are the documents available here. If I further navigate down here, that is also type airline. Now this is airport type. Here the type is airport, right? So in this bucket, we have documents where type is airline, airport, and there are many other types. Okay. All right. So let's go back to search. So I'm going to create an index, right? Okay.
So the things should be manually created.
Yeah, these things should be manually created. No. There is a way to create these indices using REST API, but I don't think it is productive because the query is very long, and to supplement this process, you have to create other steps like analysis, custom filters, daytime passes. These things are not REST aware, as far as I know. Okay, only the index can be created using the REST API. So it's better to use the web UI. Create the indices.
You think who is going to create this in the production?
I think the dedicated administrator, the deployer should create these indices. Yeah, you have to clearly the steps, set of steps. Okay. Yeah. Whole searching process will depend on the indexes you are defining, right? Simply, this is the cornerstone of your entire search process. Okay. All right. Okay. So we'll create the index name as travel bucket. Align. So this is the index name I give, and the bucket is what? Travel sample. Right now, in order to create create an index, first you need to identify document types, right? On which document types you are going to create the index, right? So here you have to define the parameter you are going to use to distinguish the document type. In my case, it's type, right? So JSON field is type, right?
Any other?
If you want, you can use it. If you are using any other field apart from type, you can specify here. For instance, if you go to the Couchbase, okay, type is now, that's why I demonstrated. There are two types. Type is airport, type is airline in this context. Okay, so I'm going to use that one. Okay, then you need to map these types to the right field. Okay, so what is the type? I'll say I want to index on type is equal to airline. Okay, so I'll disable default.
Can't we give two more things? Okay, you are giving only one. Yes.
Two, I think you can give it regex. That's a regex here. Regular expression. So in that case, you can give the regex. You can give it to root, right? Like, or you can specify doc IDs on which document IDs you can do. Right? The most general scenario is specify document type, right? That's the most practical scenario we encounter. Okay. For type, so your type is airline. Okay. This one you can keep, and you want to specify the index specified fields. So you are indexing only the specified fields in this airline document type. Okay. I say okay. Then what I'll do is I'll add the fields you need to index. So I'm inserting a child field. So what are the fields I want to index? Let's say I go here. Here itself. Yeah. So I want to index, let's say, the name field. Okay. So what I'll do is I'll specify the field is name and its type is text. Now, what is important is to specify the analyzer. Right? Now, I'm indexing the name field. Analyzer is very important. Now, analyzer is the mechanism. Analyzer is the process where you define how terms are identified in this text, right? And you can define analyzer if you want. You can add an analyzer. Analyzer is, let's say, airline analyzer. Okay, so the tokenizer is I'm selling a Unicode. What's the meaning of Unicode tokenizer? If the name field has, let's say, 3 words, it will split into 3 terms at the dynamic indexes. Right? This is based on protocol Unicode text segmentation. Right? The standard way of splitting words based on the space character, based on characters. Okay. Simply, this will identify words in the field. Okay. So I'm simply using Unicode tokenizer, and I'm saying save. Okay.
Yes.
And you can specify index, including all field input term vector. Just keep the default setting. When you click index, it will be index. Otherwise, it will not be index. Okay. I'm telling okay. So saying okay. So that's it. So those are the minimum requirement. You need to create a simple index. So type name is this one. Oh wait. One missing. Yeah. Name the analyzer. Analyzer, I just created the airline analyzer, right? So you have to specify airline. Sorry. Airline analyzer. Save. Okay. Here the analyzer should be airline analyzer. So you can see the corresponding JSON, right? So see, my field is the name, type is text, analyzer, airline analyzer, index true. Right side, you can see the corresponding JSON generated out of this thing. Right? If you are using REST API, you have to generate this entire JSON. Right? Since you need to create.
We can create the JSON and
you can create, but problem is from my explorations, I couldn't find a way to create analyzers and all. Right? Unless you have defined, multitude of analyzers available, and you can write your custom filters, custom rate time passes. For these things, I can identify the generation logic in the REST API. Once generation logic is available, then you can write the JSON and pass one query. Okay?
Analyzer is not there.
Analyzer is not there. That's the problem. Creating analyzer is not there in the REST API. That's according to my exploration. But if you explore further, you might be able to find. But I think using the console is much more efficient and easy. Right?
We have to depend on that.
Yeah, it will depend. But anyway, FTS is still new. It's evolving technology. Okay, that's why by default you don't have search enabled. You have index service, query service, data service enabled by default, right? In the Couchbase documentation itself, it says we have not enabled because there are still improvements has to be done for this search technology. Doesn't mean that it is unstable. To dictate to the customer that it is better than some other available technology, they are going to take some time, but one day they will announce it. All right. So analyzer. So I'm creating the index. So you can see the indexing is in progress. That means to go through the entire set of documents and create the index. So indexing is done. My index name is So travel bucket align and go and select align analyzer index include on field. Okay, cancel. Okay, so my indexing is done now. Let's see how we can search using the search SDK provided by the Couchbase. Okay. All right. So first we'll start with the simple query. Simple text query, bucket, travel bucket align. My index name is travel bucket align. First we'll issue a match query. Say search query.match British way field name. This is how you search based on the index field. Search query.match British way field name. So now just now we index name field, right? Now you can search from the index field called name. Okay. I'm searching British way. Let's see what type of result you are going to get when you run this sample text query. I have enabled only simple text query to give me the output. All right. Travel bucket align not found. I think the index name is different. Travel bucket dash align. Oh yeah, there is dash. Yeah, sorry, dash. Yeah. Okay. Okay, so I issued a query, British way, but it returned me British Airways, British International Helicopters. I'm displaying the search text, right? Search text and the country field both, right? It's differentiated by column. So first part you see the name text and the country, right? So first I searched for British way, but it returned me British Airways, British International Helicopters, British Airways, British Midland Regional. How? It will compare each and every token, right? So British was there. It will go and match against British, and it will go and match against way, and it combines the result and get me the result. Okay. But if you do it in a traditional way, you have to split yourself. And you think about the scalability. The scalability performance will be taken care by the FTS. Okay. All right. Now, so British way. So you only encountered search results. Only British was matching, right? So ways you couldn't match. So let's alter document and see whether you can fetch way. Okay. So I'll put way here.
The Airways, there's a way.
Yeah, but this is the match query. I'm going to explain match query.
Exactly.
It meant only the exact terms. Okay, I'll let you know how to go inside the text itself. Okay. Okay. So I'll put wait. Now let's run the query. See, airline way varies. Airtran way. So using the match query, right? You can match against each and every term in the text you pass, right? And let's say I lowercase this one, b. Now what will happen? Nothing was written. because at the time it analyzes, it considers a case. So once it is case sensitive, your search will fail, right? In order to rectify this issue, what you can do is you can go to the index. No, you can go to the search. You can order the index, right? You can go to the index. Right. Okay. This one I'll edit. I'll go to the analyzer. I'll edit the analyzer. Yeah, wait. Yeah. Yeah. Token filters. In addition to the Unicode tokenizer, I'm adding a token filter to lower. So what it does is, after the Unicode tokenization, it will take each and every token. It will lower the case. Okay. And save. Right now, I'll update the index. So it's indexing updated. Right. Now, if I search, see, fetch me the results I want. Okay. So that programmatically you don't want to lower the case.
Yes.
If you want like this. Like this. Okay. That's advantage. You don't need to lower the case. Okay. So that is mesh query. Okay, so let's go to another one, regex query. Now, using regex query, you can go in and see whether each and every portion of the text is appearing in each and every term. Okay, so simple regex query. So what I'll do is regex query. I'm matching for ITI. I'm checking whether ITI text is available anywhere in the term. Right? So I'm using same field name. This.
Yes, comment the simple text.
No. It's the reference. Okay. See the regex query. So I search for ITI. See, ITI is here, ITI is here, ITI, like that. Okay. Here it matches only the term, but if you enter a term like with space, it won't recognize, right? Like this. This won't return anything, I guess. Okay, so regex query works only for one term, right? Like this. You go in and fetch, right? So the reason behind this result is availability of ITI. ITI is here, ITI is here, ITI is here, right? Wherever the search term, if you have ITI text, it will fetch the result for you. Okay? Clear, right? Yeah, that's a regex query. Then I'll see conjunction query. Right now, conjunction query is a method that you can use to combine two search. Right? Let's say you search one field by British way matching, and you're using regex query to match ITI. Right? So here, what it should do is it will fetch me all the documents with the match British way and with regex match ITI, and it should not return me duplicates. Okay. So I'll alright. Double bucket. So you can see the conjunction query. So I search for British way, ITI. So now let's compare these two. Right now, this one British way query return me 1, 2, 3, 4, 5, right? And ITI independently fetch me 1, 2, 3, 4, 5, 10. But this one return only 4. Why? I met both conditions. I return only 4. Why?
ITI only the third one is not matching with the British way.
Yeah. So conjunction will simply perform the AND operation. That means whatever the search result should contain British way and ITI both. Right? Then only it is considered as a match. Okay. Now using these three things, you can perform any type of search you want. Yeah, conjunction, gex, and simple text. No, not the union. Intersection. Intersection. Union is the next one. Disjunction. Right. Now let's do the same thing with the disjunction. Just understand, conjunction is the intersection, and disjunction is the union. Simply it will eliminate duplicates for you. Okay. Right. Disjunction. Same thing with disjunction. 1, 2, 3, 4, 5, 6. Now it will be 6. So it's an operation. Right. I apply the same set of queries for disjunction and same set of queries for the conjunction. Conjunction return me 4, disjunction return me 6 because disjunction you consider about OR operation and the conjunction you consider about AND operation. Okay. When you combine these 4 type of queries, you can implement any type of search. Okay. Right. Now, apart from that, now let's say I define only one index field. Let's define another index field. Right. Okay. Let's go to the. We'll edit the index. So I'll add. I add only.
Let's say SQL and C. Let's say SQL and C the request going out while you're
Request not.
SQL.
Yes.
What
is that? This one.
SQL and I will see the request going out.
The
Console.
console. Okay. This one, right?
No.
But
Right click and inspect elements.
we should have read it.
Put it down. We can't go like this. Go to the
Yeah.
that 3 rows.
No.
Put it down.
Yeah. I think I'm on. Yeah. All right.
And go to the network. And close the bottom panel.
This one. Right.
Clear the.
This one. Okay. All right. Okay.
Now create an analyzer.
Yeah. Now I create analyzer.
No. Try to edit.
Okay.
Maybe the name.
Okay. In the code, I'll put filter.
You put something to the name.
Okay. Analyzer. Let's say 1. Okay.
Now check the folder.
This is going for the Angular.
No, there's a folder. And then
Pending.
That yeah, there should be, but what we don't know is whether the logic of the response is
no, you have to find
the
see without.
that will find. It's okay. You want to find the response? Yeah. I'm just trying to find out where the request was sent. Okay, let me change again. Okay, let's clear again. Okay. Edit.
Because it
Remove it again.
no.
There's evidence. Above.
Unless
We have to scroll.
This is the response.
Response Now. Any other preview response?
There. It goes only the payload.
Yeah.
What's the request?
Yeah.
UI index HTML local 8091. Like this. Yeah. Okay.
Yeah.
Authentication anyway we have to do when we use REST. We are sending authentication headers.
Yeah.
That will export data.
We can do
It's
it.
a problem. We can't explore it.
I mean, the generation of analysis to the REST API.
No, if we can't do this type of research using Gradle or something automated build tool, then it won't be accepted.
Yeah.
That up to them to accept or not.
No, it is so also, but I have to start developing.
Yeah.
That's the point.
Yeah, you start developing.
So we have to discuss this.
We'll give the stepwise document. Set up the index.
No.
But what to set up? You are getting a lot of efficiency now. You have to think about that.
That's not going to work.
Yeah, that will discuss it then. We'll discuss.
Yeah.
Otherwise, going back to N1 is not option.
We should know whether we
We should know that.
Yeah.
whether we can do this or not.
Yes. That's up to them to decide.
This cannot be done.
Yeah, that's a separate thing.
Then that's a clear sign that
That's
this is
a-
all not ready for production.
No, this is ready for production. There are a lot of use cases.
Yeah, then it should be here. The thing should be there.
Yeah. It's there. In my first class, what I explored was only the REST API to create the index.
But
I didn't check the REST UI whether
I think
Yes, you
we
are.
need to make a decision because the next week I'm going to implement the full text.
Yeah. See, decision
Yeah.
is on.
We can, first one we can do.
We have to do.
We have to do. That.
And for this sprint test, we have taken
So
the.
we have the video.
Yeah, so how are you going to do for this?
So that's why I done the R&D. So we have to finalize this thing today.
Within that hour, we can do this one.
Not for the next sprint, this sprint
This
test.
thing, yeah.
Yeah.
Yeah, the thing.
This is
Yeah.
the real one.
That do a separate R&D on that. But if you are generating a common query, you should be able to specify all this information in the.
But I need by video Wednesday.
Yeah, we will do
This is
this.
the way to do. I don't think even you can't create automated index creation script.
No.
You should not stop using FTS.
No.
Don't go beyond that till we finalize this.
Yeah, you should not drop FTS.
So we should not talk about that.
Going with NLPL is waste because it supports scalable search, right?
Yeah, so we.
Okay. All right.
But there's the way things are playing.
Yeah. But it's upsetting if they omit FTS simply because they can automate index creation, right?
And it's a sign that this is not for full-fledged production.
No, it's there. I did half exploration on REST API. Okay, it might be available. Let's see. Right. My only doubt is if you are doing a proper REST API for this, you have to provide the API for all of these things. In my first class, I didn't see the REST API for creating custom filters, data parsers, analyzers. But it has given one REST URI to create the index, specifying analyzers and type. Assuming those are predefined. Right? Okay. I'll do R&D. Okay. So we created only one index. Now, if you want to add more indexes, you can do that as well under the same index. Okay. Let's go to the this thing. Where are the documents? Okay. So I have type airline or no name airline Yavis. So we created the index out of this name. Let's say I want to create another index, country. Right. So I'll do that. So what I'll do is I will go to the search. This one, edit. My available one is the name. So analyze it. Okay. All right. So I'll add one more child field. Field name is country. And analyzer, I'll use the same analyzer. Okay. And I'll update the index. So I have two indexes now, country and name. And I'm using the same analyzer to index. So I'll update. So the indexing is in progress. Right. Now you can search by country as well. Right. So field name. So I'll put country. So United States. Oh, whatever.
One, go down.
Yeah. Okay, let's go to instead of this email code. United States. See, now I searched the index using United States on the field of country now. I'm not searching on name now. I'm searching on country. I just fill in the index. Okay, United States. So to separate research United, to separate research states. So United British Airways, the United Kingdom. United Kingdom.
It's distant.
Ah, yes, distant. Sorry. Yeah, but sample. I put the. Yeah, above. Yeah, right. Yeah. So United States, United, it will call United.
Comment other things, huh?
Yeah, just but I have the clear tag like simple text query, text query, like that, conjunction query.
So only this much of data is will states.
This is in the document. That's in the bucket.
But there were like 30,000 documents.
Yeah. But if you have any doubt, you can scan it. Right? This is correct.
I thought the whole
But around 20% of the documents are right. Around 20% airport, around 20% hotel. They are very set. I index only airline time.
Still 20% of 30,000 is 6,000 and let's say it should have about
So how many? If you are in doubt, let's type another 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, let's alter one country and see.
no, sir. You put
Yes,
Russia, you put Russia and see.
Huh?
Put Russia.
Country in the search.
This is put Russia.
Okay, Russia.
Russia.
Do you think that it will about
No, nothing. Nothing. Let's see.
France. Put France.
Yeah, put France. This is you should do after you create the application.
Why are you typing so?
So France. Okay. So like that. So functionality is correct. Okay. So in real-time examples, what you do is you create indexes out of multiple fields in the document and you use conjunction or disjunction. Right? If you want to go inside each and every phrase, you have to use disjunction with regex. Right? And you get the operation and you do disjunction with the rest of the fields. You do conjunction with one-to-one method and disjunction with regex fields. That will give you the total sorted set of results. You can perform any type of search using this set of examples. Okay, and there are additional provisions available in this API. You have wildcard query, you have phrase query method. Phrase query means it will match the phrase exactly. If you put British way, it doesn't split the British and way separately. It will go ahead and match British way exactly. Okay, but I don't think in our day-to-day examples you don't need this feature much. The most applicable features are simple text query, regex query, conjunction, disjunction, those kind of things. Okay, using these four, you can conduct any type of term search at scale. Okay, in specific scenarios, you might need find by text fuzzy, right? So if I do a fuzzy search, fuzziness and set the fuzziness to 2, it will do a fuzzy search, right? Fuzzy search means let's do one for you and see. So find text fuzzy.
So
Fuzzy means
the combination of everything.
yeah, it
Function device, output device.
Yeah. Fuzzy means the bit. It depends on how it look like. The relevance.
So is there
Relevance
is there a search combining the phrase search and simple search?
Phrase search and simple search. But thing is, when you do simple search, it has the phrase search also. You can't avoid phrase search when you do match search. Because match search,
No.
definitely the result of match search.
Say there are two objects.
Okay.
And we are searching for we have search query. So one object, one entity has part of this thing. So that should go for simple search. The other has the exact portion.
Okay. The thing is now if you
So you are saying that so that's it.
okay. Okay, let's say this British way. British way. Okay.
You want only phrase search.
Okay, both. Both. Okay, British way. So when you do British way, what it does, it will match British separately and way separately. And it also, if it is matching British and way, definitely British way also will match. Right? That's what I said. When you do match search, right? Always we have results of phrase query as well.
Yes.
Okay. What is not there is regex. There can be scenarios where British is inside a certain term, way is inside a certain term. In that case, what you need to do is you have to run a regex query across British and way separately, and you have to get the disjunction of that regex query and conjunct with simple text query. Okay, that will give you all the results. Right?
That's one line.
Yeah, that's one row. Yes, that's correct. Yeah. And for all the other indexes, now if there are any other fields, just create indexes for other document fields. And if you are doing exact match, use a phrase query and match them and get the conjunction and disjunction wherever needed, and it will give you all the results. Right? Easy as that. Scalability will be taken care of by Couchbase. Okay. So this is how FTS is implemented in Couchbase, and they have APIs for PHP, C#, Ruby, Node as well.
That is the fuzzy search.
Fuzzy search, yeah. Let me do example of fuzzy search. Yeah. Fuzziness means you understand fuzziness, right? Fuzzy means it's not exact match. It is closer. Proximity, it's kind of proximity search. Proximity search. For instance, now if you search bus, it might return a bucket casted, right? Based on the fuzziness. Okay, let's run a fuzzy query. Find by text fuzzy break. Yeah, if the more fuzziness you have, more proximity you can search. More closeness you can search more distance. It's called event distance or something, right? Event distance increases, event fuzziness increases. Okay. Okay.
What's the limit we are giving?
For this one,
Yeah.
fuzziness.
No, for other services.
Limit 10. Limit is 10.
What's
Limit you try to spend only the top 10. Right, and you can sort as well. Limit 10 now. By default, these are sorted based on the score. There's a score attached to each and every document search result. That score is calculated by the engine, and this is called the relevance index. Right? The more relevant the document is, it will be sorted out. Okay. And if you want to sort apart from the score, you can define your own sort field. Dot sort. Right, that's it. Sort and give you the results. Okay. Okay, let's go to the fuzzy search. You want to see fuzzy search, right? This is fuzzy query. I search for Brit. It returned me obit also. Right? Brit. Obit. Flying training. Yeah. Unique. IT also is returned. Okay. Fuzzy means fuzziness. Fuzzy. Fuzziness.
So,
Okay, let's reduce the fuzziness to 1. Okay,
if it's two, will it match 2 letters or
no. That is a weight attached to every integer, the fuzziness, right? That is depending on several factors. Let's reduce the fuzziness. You will get you should get lesser number of results. Here you got 1, 2, 3, 4, 5, 6. Okay. Nothing. No, you get 1. More fuzziness you get, more data you get, this is called proximity search. The proximity will be increased as you increase the percentage. Okay. So you have prefix query. If you want to search by prefix, you can use prefix query, wildcard query, phrase query, numeric range. Right? Let's say you have age field in the document. Simply you can use a numeric field range query. If you want to search age, just something, something, use a range query. And the date range. For instance, if you have to do any insertion date based query, use a date range query and it index in this console.
Data insights is there.
Yeah. And you create index here. Whatever you search should be indexed. Non-index fields are not searched. That you have to remember. If you want to search based on certain field, you have to index. Okay. If you are adding a date field, just edit it and add a field like that, and attach the analyzer. Okay. And analyzers, you can have add analyzer. These are the Unicode is the default analyzer. Okay. Unicode means it will tokenize your field text based on a concept called Unicode text segmentation. That's a standard protocol, right? It's not simple space-based tuning, space-based tokenizing. It's more than that. Okay. And you can filter by, if you want to filter apostrophes, you can filter apostrophes. Stop words, you can eliminate stop words. Insert this and are called the stop words. Okay. So you can get rid of stop words. When index, it won't index stop words. Right? There's no point of searching by this and by those things. Okay. Correct. And so date time passes. If you want to index only certain date time formats, you can index like that. Those are additional features. But to get ordinary work done, this type mapping and analyzer is more than enough. Okay. And index replicas, you can define index replicas you want. Right. At the moment, we don't have any replica set up. Right. We have only one node. We have multiple nodes in the project. It will display the total number of replicas available, and accordingly it will replicate. Let's say 3 nodes. You can set the replica. You can go up to 2 replicas. Right. Always you have to understand what is to happen on the primary replica, primary node. Right. That means yeah. Okay. All primary nodes are indexed first. In case primary is down, then we will go to the replica. Okay. And replica will be promoted immediately to the primary. That's the first thing Couchbase does. Moment primary Couchbase virtual bucket layer is down, it will promote the available replica to the primary. That's how it works. And once failover happens, you have to execute rebalance. When you execute rebalance, it will spread the load evenly again. Okay. Those are administrative workflows. Okay. Okay. Questions? Any questions we can?
That's the question. The main question is the automated next API or what is API for creation of
The yeah, that is a explorative task.
That's the big question.
Yeah.